Okay. Am I audible? Kosik? Hello?
Yes, sir, you're audible.
Okay. Shall we start? Okay. Can I start? Kosik?
Sir, I think it's already few starts, sir. Others will join as
Yeah, yeah.
time.
Okay. So, in our last class, we discussed extensively why this, I think, the previous to our last class, we discussed extensively why these points are critical in terms of the fatigue and in terms of rutting. So we need to find out the vertical strain at the top of this subgrade and the bottom of this bituminous layers. Now, in order to do that, uh, we also discussed that everything has some permissible limit. Like for these materials, if we use say different types of bitumen, different types of aggregate, then all the materials, different types of soils, then all the materials will have, different elasticity, elastic, modulus of elasticity, as well as Poisson's ratio. All this, okay. And if we know these parameters of a material, and if we know like how much stress is applied, then we can find out strain. It is as simple as that, right? That's how stress and strains are related to each other. But we also know that what should be the traffic, what is the traffic going to be on that particular road, and we know that the failure criteria is 20% of cracked area in that entire pavement, and in case of rutting it should be average depth of rutting should be 20 mm. Now, if you remember, we discussed some formulas where these formulas are again coming after a few slides, but just remember this thing. One thing is called permissible. These are the strain values which will, if anything goes beyond this permissible value, okay, if anything goes beyond this permissible value, then crack will appear and more than 20% of the area will be cracked. And again, in case of vertical strain, if anything goes beyond this permissible values, then your average starting depth will be more than 20 mm. Okay, so in order to ensure or in order to find out what is the strain getting generated because of the tires, because of the wheel rods, we need to find out this generated strain values because of the wheels, how much is getting generated here, and this will come directly from the traffic. Okay, from the traffic, if we know how this can be calculated, there also you will have to apply some formula. Here we will apply this software. But anyway, now if we need to find out the total traffic which is required to find out this permissible strain, then we need to apply this formula, right? We need to apply this formula, and we learned all the details of like each of the parameters. What is R, what is A, what is D, what is F, right? So simply, quickly, if I revise these things, A is the initial traffic, and we discussed how A is calculated after the construction period is over. Okay, that is A. So before the construction begins, if you have some traffic, that CVPD is called P. So X is the number of years required for the completion of the construction. Then you can simply find out A, and A is generally directional traffic. Okay, directional traffic. If it is divided like this, okay, but if the carriage ways are not divided, simply, or we can say it's the same pavement throughout, then you have to consider the total traffic. You should never get confused in that. Okay, So you should look carefully whether it is 4-lane divided, 4-lane undivided. So based on that, your A will come. Okay. Next, we discuss lane distribution factor. So for all the different types of roads, for single lane roads, what should be the value of D? For intermediate, what should be its value? For 2-lane two-way, what should be its value? For 4-lane single carriageway, like this previous case, like this one, what should be the value? 0.4, but dual carriageway should be, this should be considered as your A. Okay, and then you may apply the other distribution factors. Similarly, we also learned to calculate vehicle damage factor if the axle load survey spectrum is given, right? And in case the axle load spectrum is not known to you as an engineer, or maybe as a student, if that is not given in the question, then you can simply consider this. So you already know the traffic, that means the commercial vehicles per day, right? So based on the traffic values, you can find out this PDF. If it is rolling or plain terrain, simply like this, or if it is hilly terrain, these three values. Okay. So now we also learned what is EALF. We also learned about different types of axles: tandem axles, trident axles, tandem axles, single axles with single wheels on both the sides, single axle with dual wheels on both the sides, and what are the standard axle loads for it. And we also like solved this numerical, where we found out what is the PDF. And also I told, from gate point of view, this question is very important. They will give the data in a concise manner, but the concept is otherwise same. So you calculate it. So what was the value? Cosec, if you remember. Did you solve? I think it was 2.95 or something, right? Anyway. Then we also discussed design period, this N, what is N? For different types of roads, this N values will be different. Okay, generally for national highway and state highway it is 20, but minimum is 15. You cannot design a road, special pavement, for 10 years or for 5 years. Minimum it should be 15. So even in the question the type of roads is not mentioned, you have to consider minimum 15. Then traffic growth rate we discussed. What should be the value of R? So in the absence of the actual R value, we can consider a minimum of, yes, Vivas?
So it was a mistake, sorry.
Okay. Okay. So in case of in the absence of the data for these R values, we know that the minimum values considered should be 5%. Okay, but generally it is like 6.5, sometimes even as high as 7.5%. We discuss the different factors which influence this rate of growth, like the GDP, SDP, sale of automobiles. So how the automobile industry is growing. So based on different factors, we can find out this traffic growth rate. But anyway, it should be given in the question, and if it is not given, you can consider any values in between. Which is greater than 5%, and 5 to 7.5% is the range which we generally consider. Okay. So now, okay. So as I was telling that, based on the traffic, we will find out this particle strains, permissible strains. Okay, what is the permissible value? So in order to take a traffic load of this many MSA, so after all this, after getting all the value, you will calculate this value, right? you know R, you know N, you know A, D, F, you will calculate. And suppose you got, it was 40 into 10 to the power 6. That means 40 million standard excels. Now, if you know that 40 into 10 to the power 6 numbers of excels should pass without failing the pavement, then what should be the permissible strain? What should be the permissible strain at these points? Okay, if the strain at these points exceeds the permissible value, then the pavement will fail before its design life. That means if the pavement is designed for 15 years, the pavement will fail much before that. Okay, so we need to ensure that the permissible strain is always higher than the generated strain. So how to find out the permissible strain? These are the values. These are the like equations. This is NR. NR is basically same as N design. Okay. So whatever the value of N you got, say 40 into 10 to the power 6, that you simply put here, 40 into 10 to the power 6. So this, then you will get epsilon V. So whatever is epsilon V, that is your permissible strain here. You know, epsilon V is the vertical strain at the top of the subject, right? But how to find out this epsilon T is the tensile strain at the bottom of your binder course. So for that also, this formula are there. So I request you to write down these two formula, at least these two. This number 1, you write down this ANR equal to this value, this equation you write down. Done?
Yes, sir.
Okay. And for fatigue, this one.
Done.
Okay. Okay. And you also write this NF equal to NR equal to N design. So basically, this N design is basically fatigue life and rotting life. Okay. So life of a pavement is generally expressed in terms of you know, the number of standard excels it can carry without failing. Okay. So now if you see in this in the previous equation, directly this epsilon value you can find out if you know this N design. But here, in terms of this fatigue equation, we also need to know this modulus of resilience of your bituminous mix. Okay. So how to find out these things? And also you need this C. So what is C? So for C, this is the formula. C is equal to 10 to the power n. You can write down that. And n is this one. Okay. And if you go to IRC 37, all these values are given directly. What is PBE? What is PA? These things are already given. So if you know these values, you can find out what is M, and if you know what is M, you can find out what is C. Okay, and this MRM is also given in code. So now anyway, we will now find out these values and permissible strains. So this is for CTB. We will not discuss this. It's going to be more complex. But anyway, as I was telling, in our case, only 3 layers are there, right? Subgrade. This is base plus sub-base. Same material, so we are considering as 1. This is also same material, same type of material, binder plus surface. We are considering this as 1. So only 3 layers. So we need first this E1, mu1, okay, for this bituminous layers. Then again E2, mu2 for this granular layer. Granular means where aggregates are there, bituminous mix where bitumen and aggregates are there, and subgrade. Here also you need E3 and mu3. Okay, so these 3 data sets we need to know, and if I know the stress, then we know the stress or the load coming into it, then using software and later stage we will find out how to do it manually also. We can find out strain at any point, okay, at any point what is the strain getting generated, that we can find out. But our concern is we need to find out the strains only here, right? Only at the tensile strain at the bottom of your bituminous mix and vertical strain at the top of your circuit. Okay, and we also need to fix the thickness H1, H2, and generally this subgrade is 500 mm, and while doing analysis it is considered as half space. Half space means it is semi-infinite. So we will consider this as infinite in this direction. It is going like infinitely deep, okay, in one direction. So that's why it's called semi-infinite. Okay, so basically we need to find out what is the value of H1, H2. That is called design, right? In our first lecture only we discussed designing a pavement means finding out the required thickness of different layers. Okay, so how much should be H1, how much should be H2, that we need to find out accurately, because if we don't find it accurately, what will happen if the thickness, if you underestimate the thickness, that means if the required thickness is like 20 centimeter, you provide only 15 centimeter, then the pavement will fail. And if you provide 25 centimeter, then what will happen?
It will be more costly.
Yeah, it will be simply wastage of taxpayers' money, right? So as an engineer, you need to find out the optimum thickness. Okay. So now coming into that. So first we will discuss about finding this E value and mu value of this subgrade. Okay, which is made up of soil only. Alright. So for soil, how to find out the elastic modulus. And here in pavement design, this modulus of resilience and elastic modulus both are assumed to be equal. Okay, although they are not, but they are assumed to be equal. So generally, how do we find out this modulus of resilience for soil? Any idea?
No, sir.
So there is a test called triaxial test. Yeah. So if that with cyclic loads, we can find out this modulus of resilience. But this is a very costly test, this triaxial test, and also time taking. So what engineers do, they simply find out the severe value of the soil, and with some correlation they find out the modular resilience. And the correlation is that if the severe value is less than 5%, then modulus of resilience is directly 10 times of the severe. Of course, NPA, you need to be NPA, megapascal. If it is more than 5%, then you can use this formula. So please write down these two formulas also. For severe less than 5%, modulus of resilience is this one. For severe greater than 5%, modulus of resilience is this one. Now, and this mu, Poisson's ratio of soil, can be taken as 0.35 directly. Okay. Directly we can take 0.35, this mu. So please write down at least these things, and you also write down this, that E is modulus of resilience. Now, do you know how CBR test is conducted? Have you performed CBR test in lab? Proceed.
Sir, using force or something.
Yeah. So, what is the basis of this test? Like why it's called CBR? Any idea?
Sir, it is the standard test in California. Its main aim is to determine the bearing ratio of soil. I think a circular plunger is used to
Okay.
give force and see when the soil fails.
Sure. Okay. So remember it very simply. So it's basically the strength of the soil. Okay. But unit of strength is generally MPa, right? But what is the unit of CBR? It's unitless. It is expressed in percentage. Why? So you see, suppose if I take a mold, okay, I take a mold and I filled it with aggregates like that. Okay? This aggregate should be packed properly. And how do you ensure packing? With some proctor, applying some hammers, okay, just like you use in a modified proctor test. So this is properly compacted, okay, this aggregates. And suppose here you have soil. You use the same compaction technique. Using a proctor, you have compacted in 5 layers. It's like a modified proctor in 5 layers. Number of layers should be 55 in each of the layers, and like as the same hammer that you used in modified proctor that you can use here. Okay, so now when these two molds are there, which are made up of, say, this is aggregate, this is soil. Now if I use a plunger means this thing, okay, it's like a big needle sort of thing, okay, just like a big needle. If you remember the penetration test in bitumen, so there also when the needle is penetrated into the bitumen to check how hard the bitumen is, right? So here also, in order to check how hard the soil is or how hard the aggregates are, you will like start penetrating the plunger. Okay, now this engineers in California, they took these aggregates from California and they tested it. As you know, Americans' mindset, they thought that aggregates, which is like present in California, that was the strongest aggregates ever in art. So they considered those as the strongest one, and they found out the force required to penetrate 2.5 mm of the plunger. So the plunger is penetrated 2.5 mm. So in order to penetrate 2.5 mm, what is the force required? Suppose the force required is 1370 kg. It is reported by those engineers in California that in order to penetrate 2.5 mm, then we require a force of 1370 kg. Okay, and for 5 mm penetration, it is 2055 kg. Remember this values, very important. Asked everywhere. Okay, may not be in GATE nowadays, but in any other exams, these questions are asked. Okay, for 2.5 mm, what is the standard weight? For 5 mm, what is the standard weight? Anyway, so they got that these values. Now, they suppose now you have your own soil collected from your hut or Sipsana. Okay, so you compact it using the same method. Now you try to penetrate the plunger. You are just reading your penetration with a dial gauge and also the force you are applying. So For 0 mm penetration, you don't require force, right? So for 1 mm penetration, you need some force. Okay, so in terms of kg, it's a 100 kg you need. Okay, for 2.5 mm, suppose you need 137 kg. Okay, for 5 mm, you require say 205 kg, like that. Okay, so what you will tell that the severe value of this soil is 137 by 1370 into 100. It will be 10%. It is always compared with the standard values. So standard values were this. Okay. Have you understood?
Yes, sir.
Okay, so that's what severe is. So it is a very simple test. I think you also have a setup in your lab. So simply you can take some soil, then some protocols are there. You need to submerge, so you need to prepare the mold using modified process method. Then you need to submerge the soil under water for 4 days to simulate a worst condition. Then you will take it out and you apply the plunger and you find out what is the force effect. Okay, so understood, no? So 10% severe means this one. In order to penetrate 2.5 mm, you require around 37 kg. Now my one question to you: can CBR be more than 100%?
Yes, sir.
Why?
Sir, because the engineers of California actually measured their aggregate and took it as the maximum. So
Yeah.
if some aggregate which is more stronger than those, it will be of course more than 100%.
Yes, very good. Very good question. So these are the modulus of resilience which are directly correlated with severe. Okay, and this is nothing but your elastic modulus also in this context of pavement design. Okay, so you simply find out the severe value and you will get your modulus of resilience. So now we can say that this layer is done. As we know, 3 layers are there. One is the bituminous mix, then we have this granular layer, base and subbase, and the subbed, soil subbed. So soil subbed is done. We know now which value to take. You simply collect the severe value and use this formula and you will get E3, that is the modulus of elasticity of this material, and mu3 is directly suggested, so we should take it as 0.35. Okay, now let's move to next layer. Okay, so now here as we know that we had different types. Sometimes it may be cement treated base, cement treated subbase, granular subbase, granular base. So now if I again divide these layers accurately into its components, this is sublet, this is subbase, this is base. So these two are generally considered as the same layer, granular layer, even for design. And this was a surface course and binder course. This was a bituminous mix. So here also in granular layer, if you see, there are 2 layers, like one is subbase, one is base. So first let's discuss about this granular subbase. So this granular subbase is calculated like this, with this formula. You may write down this formula, okay, which is like modulus of resilience of the granular layer is 0.2 h to the power 0.45 and modulus of layer of the support. Support means where it is rested. So in this case it is rested on the sublet. So this support is basically sublet. And what is this modulus of resilience of sublet? That you just found out, right? This value. Okay. Based on the severe value, either this or this. Right. Basically, it is E3, isn't it? Are you getting? So based on your E3 or MR subgrade, now you can find out your E2 or your MR plane. Okay. So this is the main disadvantage of this code, because you are taking help of another layer to predict its elastic modulus. Okay, you are assuming that you are actually not at all considering what type of materials are being put inside this. Okay? What type of aggregates? Aggregate also has different strength, right? So what type of aggregates are being used? You are not at all considering. You are simply taking help of the below layer to find out the elastic modulus of this above layer. Okay, this is wrong actually, but there are no other way to find out. So of course you can find out in lab, but if you don't want to follow that route, that means taking the materials and testing it in laboratory with dry axial test, then this is the alternate route. You have to find out like this. Okay, what about its Poisson's ratio? This is again suggested that you can use 0.35. Okay, till now understood?
Yes.
Now if it is CTSB, although we are not discussing this compositions, but in case suppose this is a CTSB layer, it's cement treated surface, not granular surface. This is granular surface mixed with cement. Okay, so in that case, this MR or this E, same thing, this is calculated like this. What is this UCS? Unconfined progressive strength. Okay, so you must have done this test, right, in soil mechanics lab, geotechnical lab. Have you?
No, sir. There is apparatus, and the final year students who get them as their project, they use it, but we do not have it in our syllabus of fifth.
Okay. Anyway, this value can be found out like this, and the Poisson's ratio is 0.25. This is because this is cement, right? It doesn't have much of flexibility. This should be rigid kind of thing. So that's why Poisson's ratio is also less. I hope you know what is Poisson's ratio, right? Vivas?
Yes, sir.
Vivas, do you know what is Poisson's ratio? Shall I like refresh? So this is the
Yes, to
material.
strain, sir. Ratio of stress and strain, I guess.
No, that is elastic modulus. Suppose this is a material and you are applying force like this, and when you apply force like this, it will change its shape. Okay? It will elongate like this. Okay, it will be now in this shape. So suppose the cross section was circular. Okay, so earlier the radius of this section was say R2, now it is R1, and the length was say R1, now it's R2, now the length is increased. So this Poisson's ratio is nothing but delta R by R1 divided by delta L by L1. Okay, this is your Poisson's ratio. What is delta R? Basically R2 minus R1. Okay, and delta L is R2 minus R1. Now do you remember?
So let us just along with it.
Yes, lateral strain divided by longitudinal strain. Okay, very good. Now we have discussed sub-base, right? So what about granular base? So here again, two cases are there. If you remember, either both the layers can be granular base and sub-base. Then what you have to do, you have to simply consider this. If you remember in the formula, this was H, right? H was this, only granular subbase in that case. Okay, now it depends above this granular subbase whether you have granular base. If you have granular base here also, then this H will be like considering both base and subbase. So in our example, we will be considering it like that only. But if you provide CTSB instead of granular subbase, then you have to go to test 2 and find out what are the different suggestions. Okay, should be 300 to 380 like that. Okay, but in our case, since we are using same granular material in GSP as well as granular base, so we need to consider this formula, same formula, but now H will be more like this, base plus subbase, the total thickness. Okay, now similarly this base can be again CTB. So for CTB we have to find it like this. Okay, what should be the Poisson's ratio? It will be like this. So like that. Now if you are using CTB, if you remember earlier second class we discussed that cement is like it will give some rigidity to the layer, right? So there may be some possible chances of crack, okay, in these layers. So since this is modified with cement, so because of high rigidity and with some load, these layers may get cracked. And in order to prevent these cracks to get propagated to the bituminous layers, what we do, we provide some layers in between, okay, which we will call crack relief layer. Okay, this will stop the crack to get propagated, because this layer will be very much it can be either a granular layer, okay, granular layer. So in this case it's granular layer like this, or it can be a stress absorbing membrane interlayer, SAMI. So this is just like a mixture of modified binder and little bit of aggregates. So this will absorb the stress coming due to the crack. So that's why we call stress absorbing membrane. So we will not discuss this because we are not using CTB as our base layer. We are using granular base, right? So we don't have to provide these layers. Okay? But I thought that you should know this different types of possibilities. Okay, that's why I kept it in the slides. Now coming to the most important layer, which is the bituminous layer. Okay, and as you know, there are two bituminous layers in flexible pavement. One is called surface or wearing course, and the second one is binder course. Of course, a tech coat in between them. So this bituminous mixes, as you know that there are different types of bitumen. Okay, so different types of bitumen, there are different advancements in bituminous technology also. So there can be different varieties. So which variety should be used in your case, that is already suggested in your IRC. So IRC says that if your traffic, if you remember this n value you calculate, suppose it is 60 into 10 to the power 6, it means 60 MSA. So if it is more than 50 MSA, then you have to go for this SMA, stone matrix spot, with modified or VG40 vendor. If you want, I can discuss what is all these things. Okay, so let me know if you want. Do you want what is? Do you want me to discuss what is this? What is this? Understand?
Yes, sir.
Okay, so if it is in between 20 to 50, then bituminous will be this. less than 20, then this. Now you see, okay, generally if you know, if I ask you like how many types of bitumen you know, and one of you answer from your knowledge, whatever you learned in highway engineering, what are the different types of bitumen that you learned? Anything? Different types of bitumen. Any name?
Sir, we mainly use bitumen emulsion, I think.
Okay.
And sir, there are some modified polymer bitumen.
Hmm.
And sometimes I have also heard of oxidized grade bitumen, and I can't remember it.
Okay. Okay. All right. So okay. So you see, bitumen. How bitumen is produced?
So from petroleum.
From petroleum. So you have petroleum. Okay, that is taken into some vacuum tower. Okay, and this vacuum tower, you know, uh, uh, is heated. Okay, so at different temperature, you know, different components of the petroleum will evacuate. Okay,
Fractional distillation, I think.
yes, this process is called fractional distillation. Okay, I think you learned this thing in class 11, 12.
Yes, sir.
Right. So, if someone asks you how bitumen is obtained, you have to answer like an engineer. You can tell bitumen is obtained by performing fractional distillation on petroleum. Okay, so what are the other? Bitumen has the highest melting point, as such the highest boiling point also. So it is obtained at the bottom. It's also called vacuum tower bottom. Okay, so this is bitumen. Can you name some other products? Ankur, can you name some other products that we get from fractional distillation of petroleum?
Yes, sir.
So
Some natural
diesel,
gas.
wax and all.
Okay, let me know other thing.
Sir, crude oil.
Crude oil is petroleum.
Oh, sorry, sir. Then some kind of natural gas, maybe.
Okay, natural gas will go up like this. Then,
Asphalt.
uh-huh,
Asphalt.
spal is petroleum.
Oh,
Same thing.
yes.
Then,
So petrol.
yes, yeah, petrol, diesel, kerosene.
Yes, sir. Then sir, waxes. Some.
Yeah, petrol, diesel, kerosene. So based on their, boiling points, this liquid will evaporate at different heights. Okay. So bitumen is obtained from the bottom of the tower. So this is bitumen. Okay, bitumen. I think all of you have seen at least how bitumen looks, right?
Yes, sir.
Okay. So what is the state of bitumen?
It's a semi-solid.
Always semi-solid.
Sir, depending on temperature, at room temperature, I
Yes.
think it is solid.
Yes. So bitumen is called thermoplastic. Yeah, thermoplastic actually. So basically, it changes its behavior based on temperature. So at higher temperature, it will behave like a liquid, just like water. And at lower temperature, so if the temperature is less than 20 degrees centigrade, it will be like a semi-solid. And if the temperature even goes below that, it will be just like very solid. Okay, so it depends on the temperature. But anyway, we can heat the bitumen to make it flowable. We can pour it somewhere. Then again, after some time, bitumen will cool down and it will be solid again. Anyway, this bitumen is, neat bitumen. Okay, this is neat bitumen, or we also call it virgin binder. Bitumen is basically a binder. Okay, it's called virgin binder. Okay, but as Kaushik earlier mentioned, this bitumen can be modified. Okay, based on your requirements. Nowadays, because of this expressways and all, the bitumen has to be more ductile. Okay, I think you have performed this ductility test on bitumen, where bitumen is stretched like a thread. Have you?
Yes, sir. In a
Yes,
water
sir.
bath, it is.
In a whatever stretched. What is the ductility value? Do you remember? That
Sir,
It
around
is less than 100.
73.
uh-huh.
Around 73 we got
73. Okay.
centimeter.
Okay. So, do you think this is good enough? See, every test will give you some result, except what?
Acceptable, I guess.
See, anything less than 75 is not acceptable. Okay. So, bitumen should have minimum ductility value of 75 centimeter if you want to use it in acids or NH. But if you want to use in expressways, high density corridors, then it should be 100 plus. Okay, so with virgin binder, this we cannot obtain 100 plus of ductility value. So, how to increase its ductility?
Sir, by modifying it with some kind of polymer.
Okay, what kind of polymer? What comes to your mind when I talk about ductility? That can be
Sir,
stretched,
rubber or something.
rubber. Okay, so there are two types of modified bitumens available in market. One is called PMB, which is, what can be the full form? Any guess?
Some modified bitumen. Sir.
It's polymer modified bitumen. Okay, and another one is CRMB. What can be CRMB? Any wild guess? Scrum rubber. Okay, scrum rubber modified bitumen. So from where this scrum rubber comes? From the tires. If you see, many tires are, after it is worn out completely, they are simply dumped somewhere, right? So these tires are ground. Okay, and these ground particles are added to the bitumen, and after this addition, the bitumen gets enhanced in terms of their ductility. It can get more stretched. Okay, so that bitumen will be called scrum rubber modified bitumen. Yesterday, I saw one video in Facebook. So it was like investment. Okay, so they were telling that this scrum rubber producing company, there is only one in India. Okay, there is only one in India which produces this scrum rubber that goes into bitumen. Okay, since there is only one, and with this increase in population, increase in traffic demand, we need this type of modified bitumen more and more. And because of that, their sale is increasing like anything. And in stock market, they are giving like almost 414% return to the investors. Okay, isn't this like amazing? How these things are related to anything, and how, if you know the details, minor details of these things, you can invest also very scientifically on proper companies. It's not like always investing in Tata or Birla will give you good returns, right? So that is just the thing. Anyway, one is virgin bitumen, one is modified bitumen. Okay, it's modified bitumen. Now, this virgin bitumen or neat bitumen, it's again, you know, classified based on its viscosity. Viscosity, as you know, is the resistance to flow. Okay, so how much viscous the bitumen is, based on that, it is classified as in four categories: Vg10, Vg20, Vg30, and Vg40. Okay, so what is this Vg? V for viscosity and G for gradient. Viscosity gradient 10, viscosity gradient 20, 30, 40. Okay, and how to know which grade of bitumen that is? Suppose you got the bitumen. Now, how to know that which grade it is? So, what we do? We okay. So we take a manometer like this. Okay, and this bitumen is there at 60 degrees centigrade. This is surrounded by some oil liquids. So we suck the bitumen with 300 kilopascal, and the bitumen will rise. Okay, there will be some markings. We note down the markings. We note down the times required to cross from one marking to another, and then some calibration constants are there. After multiplying the constants, you get the viscosity of the bitumen at 60 degrees centigrade. And what is the unit of viscosity? Dynamic viscosity. Cosmic.
Newton per meter.
Are you sure? Unit of viscosity.
Is it poise or poisoletras?
It's poise. This is, I think, 0.1 poise is 1 Pascal per second.
So 1 centipoise is, I think, 1 Pascal per second.
Okay. So is it correct, or it is 10? 10 poise is 1 Pascal per second. Are you saying that?
Yes, sir. It was something like, I remember that it was not exactly 1 to 1.
Okay, yeah. So it is differentiated by factor of 10. So either this is 10 or this is 10. Anyway, you will get your value directly in poise. So now, these grades, Vg10, 20, I will give you one formula to remember. So take a range of 100 plus minus 20 and then multiply with these grades. So Vg30, say for Vg30 bitumen, you multiply this with 10. So how much it will be? 80 into 30 to how much? 120 into 30. So it will be 2400 to 3600 poise. That means Vg30 bitumen will have viscosity of this much at 60 degree centigrade. Okay. Similarly, for Vg10, it will be how much? Reverse. Vg10, starting with the range 80 into 10 to 120 into 10. That means 800 to 1200 volts. Okay. So if you test the bitumen, if you know that this much is there, this much is its viscosity, then you know the grade. Okay. But sometimes you really don't get the required viscosity. Okay, suppose you have obtained a viscosity of 500 twice. You want Vg 10. Okay, so you need to increase its viscosity. Remember, the temperature is 60 degrees centigrade. Okay, so you cannot tell that at lower temperature the viscosity will be high. Of course, it will be high, but we are comparing the viscosity at the same temperature, 60 degrees centigrade. So what is done? I think Kaushik mentioned one term, oxidized bitumen. So you will blow air, hot air into the bitumen. So when you blow hot air, the evaporable portion of the bitumen gets evaporated. Okay, and thus the remaining portion will give some brittleness. Okay, and it will be hard. So when it is hard, you will get more viscosity because the resistance to flow will be more. So like that you can convert Vg10 bitumen to Vg20, Vg20 to Vg30, like that. Okay,
Yes.
but the problem is that if we do that more and more, then bitumen will also lose its ductility, right? But ductility value minimum should be 75, isn't it? So that also has to be kept in mind. So that's why nowadays in order to enhance the ductility, it's modified. The other types of bitumen that you mentioned, emulsion, those are not bitumen. Okay, those are mixers. Emulsion is a mixture of bitumen plus water. Cutback is a mixture of bitumen plus some liquids like petrol, diesel, kerosene, like that. So actually, don't mind. I thought you already know these things. That's why I didn't keep these things in this course, because this is I thought this should have been the advanced level, and these things are generally taught in 5th semester. So if you need some basics of these materials, because these questions will be hunting you throughout. As a civil engineer, you will have to always face what is bitumen, what is cutback bitumen, what is emulsion, how emulsion is prepared. These things you have to face every time. So if you need, I can take 1 or 2 classes on this, maybe at the later stage. You just let me know. Wait, I've lost connection. Okay. So understood these things?
Yes, sir.
Okay. Now coming into different types of bitumen that is used here. Now you will know it better. This is called stone matrix spar. So here what is happened? Generally this bitumen plus aggregate is there. Right? So bitumen is heated, it becomes liquid. Then you have aggregates. So you pour the bitumen with aggregates, you mix it, then the aggregates coated with bitumen. So when you compact those aggregates, they get bound together because bitumen is now holding the aggregates together as a binder. So in order to enhance the properties of this bitumen, I discussed modified bitumen is there. Okay. One other thing is there that if that bitumen, when it is in hot state, you can apply some dust filler, 75 micron passing materials. It's filler, no? When you sip, you see some materials are all dust, right? So these materials you can add with bitumen. So bitumen will become more thicker. Okay, so that bitumen, when it is added with aggregate, they will have much more strength. This mixer, that is called stone matrix asphalt. So that you can do it VG40 with modified bitumen or VG40. Now we know what is VG40 vendor. Gap graded mix with rubberized bitumen, GGRB. Okay, so gap graded means there will be less air voids that you can use. Bituminous concrete with modified binders. Bituminous concrete means, although the term concrete is used, but there is no cement here. Okay, so the binder is bitumen itself. So bitumen plus aggregates. The aggregates should be very well graded. That means there should be very less air voids. Okay, then only it's called bituminous concrete. If the air voids are higher, aggregate sizes are also higher, it will be called bituminous macadam or dense bituminous macadam. If you see, this is for surface course, this is for binder course. See, surface course, I also discussed this thing in our first class itself. There can be different layers, right? So surface course and your binder course both are same, but since the load is getting distributed, so you can afford to have inferior quality materials just to cut down the cost. You should not have high quality materials throughout these two layers. One layer you can provide high quality materials, the second layer you can provide low quality materials. So in the surface course, you can simply provide this dense bituminous material where the aggregate sizes will be large, so the cost is also reduced. So with VG40 bitumen, VG40, and here you see modified, only modified. Okay, stone matrix asphalt. So here directly you can use VG40. If the traffic is less, you can see for surface course you can use bituminous concrete with VG40 or ABC. This also you can use because these are anyway superior to this, right? So ABC or D also you can use. If it is less, then bituminous concrete, semi-dense bituminous concrete. So semi-dense means the air voids will be a little bit more. Okay, that will not be properly well graded. D-mix carpet, as you see in the rural roads, this much thin, generally 25 mm thick layers are provided, especially in earlier roads. So that's called pre-mix carpet. Mix, seal surfacing, surface lacing. I think I will take an extra class to explain these things in details. Maybe while discussing this pavement maintenance part, where I'll discuss these things. Okay. So anyway, we know now what material to be used based on the traffic. But knowing the material is not enough. What we actually want to know? We want to know the strains, right? Not here, here. In order to know the strain, what are the other parameters that should be known?
CBR.
CBR is only for granular materials, for bituminous materials. Basically, from CBR also, what are you finding ultimately? Yeah.
The strength of
Elastic modulus or modulus of resilience, right? So basically E and mu. So same thing for bituminous mix also, we need to find out E and mu. So this E and mu, based on the material, it's already given in IRC. What are the resilient modulus? It's MR or E. E1 in our case. Okay, so if you are using BCM, bituminous concrete or DPM with VG10, based on the temperature, say the temperature is 35, so it should be 1000, it should be 2000. For VG40, you see, it is getting stiffer and stiffer. elastic limit is increasing, means you are increasing the stiffness of the bitumen. For modified bitumen, it will be even for modified bitumen it is lesser because uh, you know we provide some kind of flexibility, or how can I explain? The rigidity is now not there. It is more elastic, opposite of elastic. It is more flexible in nature. So that's why these values are reducing. Anyway, Poisson's ratio is again 0.35. So ultimately, to sum up, this is the table. So for all the layers, first for bituminous mix, this way. So if it is Pg30, then either you test directly, you do different tests to find out what is the molecular resilience or elastic limit, or in case of that, if you don't have, you consider 2000. If you have tested it and you have found less than 2000, then you have to take a lesser value, because you cannot overestimate. In engineering, everything should be underestimated, right? So you have to take the lower value. So similarly for PG40, 3000 what is different. So consider 3000 only. So also consider 2000 like that. Cement treated base 5000. These are elastic limit or elastic modulus or modulus of resilience. Okay. For granular interlayer 450, cement treated surface 600, unbound granular layers. So with that we can find out if you know the values of subgrade from severe. So if you do one problem, everything will be clear. If you are not following me, don't worry, we will solve one numerical from starting so that everything is clear. Okay. So now, as you know, that ultimately we need to find out the thickness of the layers, right? Thickness of the surface course, thickness of the base course. WMM is wet mix cathode generally. So this surface base is a term which will confuse you. So remember binder course. So this surface and binder together is our the first layer. Okay? This surface, this is binder. So this is bituminous mix, right? These two, and these two is our, this is base, this is subbase. Okay? So these two together is called your granular layer, like that. So here these two is your bituminous mix and these two is your granular. And why subgrade is not provided? Because generally it is provided as 500 meter, and for analysis we don't need subbase because we consider this as to be half space, means infinitely deep. Okay. Now in order to design, if you remember from your structural design class, we have to start with some what is the procedure of structural design of a beam. Can anyone remind me? Proceed. Not only a beam, any element of a building. What is the basic?
So we have to first determine how much strength is actually required, design strength.
Okay. Then
Sir, we use the
designing means I want to know what should be the dimension of the column or beam. What is the basic principle? Or how do you start? How do you start your design? We assume with our first initial trial value, right? We assume as 200 by 200.
yes.
Okay. Then we proceed. We analyze. We find out. We check whether that dimension is sufficient or not. If it is not sufficient, then again we increase. Right?
Yes, sir.
So here also it's same. but you need uh, in beam, how do you take the first value? Like what should be the depth of the beam? What should be its width? How do you consider the initial value?
Sir, it actually depends upon how much load or something is.
So we need to, I guess, find out the area first.
Okay. Here in
Then
pavement,
assume any either depth. Then we assume one depth and find out the corresponding width.
yes, yes. So since here those kind of luxury is not there, so IRC has suggested different plates. Okay, these are called plates. So design charts basically, catalog for the initial, initial thicknesses that needs to be considered. Okay, so this charts vary with CBR percentage as well as you can see the traffic. So these two things you should know: the CBR percentage, the CBR of the subject, means the CBR of the soil that you are using in the subject. That is your foundation, right? So you should know where you are constructing the pavement, whether it is in a weak foundation or in a strong foundation. Okay, based on the CBR value and also the traffic. So there are many plates. I have just taken one example. This is plate number 4. So for CBR 9%, there will be another figure like this, where the values will be different. So what I want to understand is the concept behind these plates. So if you can see, as the traffic in MSA, okay, so 40 MSA means 40 into 10 power 6. That was the N value that we calculated. So as the traffic is increasing, you can see this thicknesses that are needed to provide is also increasing, right? It was 150 here for 5 MSA traffic. For 10 MSA, it has increased to 200, right? So here, this values from 30 to 40 it has increased like that. Why so? Why?
Sir, because as our traffic is increasing, we need to provide greater thickness for sustaining the same.
Yeah, basically that concept. But my question to you will be now this: what will be the relation with CBR? Say my CBR is 7% now. For the same traffic, 5 MSA, if my CBR is 7%, then this thickness will be more or less.
More, sir.
Why?
Sir, since the CVR is less than, it means that the strength of the materials is less. So more of the thickness has to be provided for the same strength.
It is not the material. CBR is only for the CBR is not for these layers. Okay, CBR is for the layer underneath. That is the soil substrate. These layers are surface, binder, base, and subbase only. But CBR is for the lower layers, lower layer substrate.
So then I think, sir, then the thickness has to be decreased.
Decreased. Okay, why so?
Sir, because the lower layer cannot sustain that kind of weight or thickness for if the same kind of thickness is given.
Okay, so now consider two scenarios. Okay, two roads are being constructed parallelly like this. One already has a weak subject or foundation. One has a strong one. Remember, traffic will be same. 5 MSA here, 5 MSA here. So the foundation is already weak, and you are again reducing the thickness of the upper layer. So do you think it will be sustaining 5 MSA traffic?
No, sorry, sir. I think I was wrong in my logic. Actually, the thickness should be increased because as we go to the bottom, the pressure decreases from that point on.
Yeah. So it's, you can consider as like the foundation is weak, so that weakness has to be, you know, compensated by providing a better pavement. When we say pavement, here you see pavement thickness. So pavement starts after the subgrade only. The soil part, soil subgrade, is not a part of the pavement. Okay, pavement thickness is above the soil subgrade. So the pavement has to be strong. When it is more, when it is more thicker, then the you know, like this, when it is more thicker. Earlier, okay, you see, say here CBR is 7%. Here CBR is say 9%. Okay, so in 9%, if I provide this much thick pavement, you know the load is distributed like this. So once it reaches this, say area is, load is same P. Okay, here P. Now this area is say A2. So P by A2 will be something. So this is stress. Okay. So here also you want to have the same stress. Okay. Same stress. Or it should be even lower because the CBR is less. So if you provide the same stress as you are providing here, this material may fail. So you need to even lower the stress getting generated here. But the load coming is same P. So how will you lower this sigma value? So you need
Sir,
to
by increasing the thickness.
increasing this area, right? So how will you increase the area? Because it will always come like this. So you need to increase the thickness. Okay. If you provide like this, then it will be like this only. So this area will be less, and ultimately more stress will be here. So are you able to understand the concept?
Yes, sir.
So this is how these things are done. Okay. So now this is the challenge. So this is Chennai, where I am sitting now. This is Mumbai. So already some roads are there. You can see existing roads like this, like this. But I want to construct a new road. A new road connecting Chennai to Mumbai. And new road means everything is new. Okay, it's not like that upgrading some rural roads to national highway, not like that. Everything should be new. New alignment. Okay, this should go. Basically, I want you to design all the thicknesses of the roads. So, design the road as a flexible pavement. Just find out the thickness of different layers. Okay, so now what will be our, so you joined one company. Okay, that is the first task given to you. Okay, Ankur, you have joined. I think you already know how to do pavement design. So you need to design this road. So what will be your first step? My question is open to all of you. What will be your first step? From all the things that you have learned till now.
Sir, determining the strength of the subgrade first.
Yes, good. So you want, how will you do that?
Sir, by using CBR values.
CBR values. Do you think CBR will be same everywhere?
No, sir.
No. So
So we have to take a survey at different points at intervals of some
Then
distance.
based on the soil subgrade values, okay, CBR values, we may split the roads into different categories. Okay, so after splitting, you can consider this as a different road, this is a different road, like that. Then we will design the thickness of layer. Different, maybe different rate, maybe different. But for your convenience, let's say the CBR is same throughout. Okay, CBR is same throughout. I have given say 9% CBR. Now,
So we'll find out the resilient modulus of the above layers by using the CBR of the subgrade.
okay, fair enough. But before that, we learned about this traffic thing. We should know what should be the traffic.
Yes, so we have to conduct a traffic survey as well to understand how much traffic should be routed to that.
Yes. So, the first step should be estimating the design traffic. Okay. So, these different parameters. Let's see. So, first we need to find out this A. Okay. So, this A is generally P into n plus r to the power x. What was P? Number of CVPD commercial vehicles per day as per the last count. Okay. So, but other thing you have to notice here is a national highway and which is 4 lane divided. Okay. So since it is 4 lane divided, this CVPD is say summed for both the directions. Okay, it's summed for both the directions, just like this. Yes, and you have summed this one as well as this one. Okay, that you have recorded as P before the construction starts. So generally, it is collected from traffic survey, origin destination survey. Now you may ask, where you will conduct traffic survey? There is no road. If there is no road, it is going to be a new road. Okay, there will be traffic. Then how will you know? Okay.
So we have to look at the population as well, and we have to look at nearby roads as to how much traffic would be routed through that road.
Yes. So one survey is there, which is called origin destination survey. So in the existing roads, so say here, you go here, stop this random vehicles and you ask from where you are going to which place you will be going. Will you like if there a new road will be there, then will you be able to will you use that road because it is going to be a little bit shorter. So some trucks which are carrying goods from Chennai to Mumbai or Mumbai to Chennai, they will definitely say, yeah, we will use, because for us anyway we need to directly go to Chennai. We don't stop midway. So we will go for that road if it is costing us less fuel. Okay. So that kind of survey is there. One survey is there which is called household survey. Household survey means in every house you go and ask like which road you prefer. So this is a huge, like very long road. So generally for this kind of roads, household survey will not work. So you cannot go to every household of Chennai and Mumbai, right? So household survey will not work, right? So for origin and destination survey, and you also get some idea about this diverted traffic. Diverted traffic means suppose there are some roads here which are like this, from one place to another. These vehicles are going from this place to this place. But once this road is constructed, they will simply divert their route through this. this type of diverted traffic also you need to consider. Okay, but there are many factors. Traffic survey is not only the only one. There are many factors you need to consider, and ultimately you will get is 2,000 commercial vehicles per day. Construction period. Let's say this is for only in 2 years we'll be able to complete construction. Okay, it's assumed one. Traffic growth rate not given, but minimum 5% should be taken as per IRC. So you have taken 6%. Okay. Design period and indirectly given it's a national highway, so you have to design for 20 years. Vehicle damage factor. Okay, not given. Okay, not given. Even the axle spectrum is not given, but you know that this is a plain terrain. Okay, and the initial two-way traffic is more than 1500 cbpt. So if you remember, there is to be a table, find out VDF. So from that table you have got 5. Okay, and lateral distribution vector, if you see, it's given in IRC. So provided we take traffic of one direction only as A. Okay, so now this 3000 cbpt is summed for both the directions, but we know that for divided carriageway this A should be separated for only one way, right? So in this case we need to divide it by 2 at the later stage. So when we do it like this, the first step will be P should be divided by 200 because it's a divided carriageway. 4 lane, 2 lane this way, 2 lane this way. Okay, so in one direction only 1500. Now are you writing along with me?
Yes, sir, I'm writing now.
Yes, sir. So what will be A? With this rate of growth is 6%. This year required for construction, completing the construction is 2 years, so 1686 cbpt. Okay. So if you know this A, you already know D and F. You write down these values. N is 20, F is 5, D is 0.75, R is 0.06. Okay. Now find out what will be its value. Please do it yourself. Then only you will get to know. I should have hidden this. Okay. How much you are getting? Anyone?
So I'm calculating.
I think you are using a old calculator, which it's taking time, right?
No, sir, I'm actually using the engineering calculator, but I did not have it handy right now. I just worked.
Okay. If you remember in our last class I discussed, you should keep the calculator handy for this session. In the next session, that is tomorrow, you need to keep your laptops also along with you. Maybe you can view the what's the Let's
Sir,
start
2.1.
2.1. 2.1 what?
Sir, 2.1236.
2.1236 what? That is the value? Or into 10 to the power 6 or
Yes,
something?
sir, MSA.
No, I think somewhere we have. Now check this and check where you have committed a mistake. Where is the mistake?
Sir, the F value was wrong.
Okay. Now is it coming?
Yes, sir. It is 84,890,568.64.
Okay. So divided by 10 to the power 6 will be your MSA. Right?
Yes.
Okay. Now, as we know this, let's calculate the permissible strains. Okay. Permissible strain. So we know that the permissible strain should be higher than the generated strain. Okay. So the permissible strain needs to be calculated. Or okay, before that, you need to decide. As a PEM engineer, you should decide what catalog you are going to use. Okay, as I said in our second class, that you have to decide this catalog based on the availability of the materials. If you don't have much aggregates, then you have to go for cemented base or cemented sub base, because that will reduce the thickness of the layers. And when the thickness of the layers get reduced, the amount of aggregates required will also get reduced. Okay, in this case, let's say, assuming there is no scarcity of missile aggregates. So in that case, let's go for design catalog A, which is soil subbed, granular subbase, granular base, then binder course and surface course. Right? So what we need to find out? We need to find out the thickness of all these layers. Okay, understood?
Yes, sir.
Okay. Now we have to go for trial 1. So in trial 1, if you see, the traffic in MSA is how much? 84.9. Okay, and CVR value is not given, so let's say we have assumed 9%. So CVR is 9% and traffic is 84. And if you say, if traffic is more than 50, there is no play. That means the minimum should be, you can take for 50, and it will be of course more than that. So let's start with this level, this thickness is only. That means 40 is my, like this. So 40 is my surface course, 110 is my binder force, is 250 is my base course, is 200 is my surface course. Okay, that means my bituminous mix total is 150. This total is, and this subgrade is considered half space, which is infinite. So generally 500 mm is perfect. Okay, so clear up to this part?
Yes, sir.
Okay, now we need to know the materials, because knowing the thickness is just the beginning, right? Because this is not a final thickness, this is just an assumption. We need to find out the strain generated here as well as here. So in order to find out the strain, we need to know the modulus of elasticity or modulus of resilience and the Poisson's ratio, right? For this same, even for this, again for this. So, in order to know the modulus of elasticity and Poisson's ratio, we need to find out what materials you are using. So, subgrade is generally soil and CBR is 9%, that is given or we have assumed. The subbase is granular materials, this base again granular materials, WMN, GSP is given in ISA. This binder course and surface course, we can have a look here. Remember, our traffic is 84.9 LSA, that means this. So, we can consider this bituminous concrete modified binders and DBM with VG40 for surface and binder course. Okay. So if we know that, then we can find out. For our simplicity, we can simply say that BC and DBM with VG40 is around 3000 MPa. Also, it's given here. You can see bituminous layer with VG40 or modified bitumen, both are same, which is 3000 MPa. So, modulus of elasticity of that bitumen layer is found. In Poisson's ratio is 0.35. Similarly, for subgrade, it's calculated from CBR in Poisson's ratio 0.35. For granular layer, this is calculated using this formula and Poisson's ratio is 0.35. Now, I want you to calculate for all the layers. Okay. First, you tell me for subgrade. Okay, for subgrade. That is E3. Mu is 0.35, you already know. That is the subgrade, E3 or MR. Did you write down the formula from CBR?
Yes, sir.
MR. So, which formula will be used?
So for CBR, less than 5% or so greater? It's greater than 5%.
Yeah, CBR is 9% here.
Yes, sir.
The CBR of this soil is 9%.
Yes, sir. This is 17.6 CBR.
So we have to use this formula. So how much we are getting?
So 3.76.
No,
Sir, the CBR is input in decimal or percentage, sir?
no, it's percentage.
So 71.81.
So 71.8. Okay. Now you know E3. Now let's find out E2 and mu2. Mu2 is 0.35 directly given. What will be E2? That means modulus of resilience or elastic modulus of your granular layers. So what is the formula? 0.2 h to the power 0.45 then into also forgot into MR support. That means E2, so E3, right? Into E3. Which is the support, right? Subgrade. It is MR support. MR subgrade. Same thing. So this is H. So did you write down what will be the H here?
Yes, sir. 200 millimeters.
No,
450.
because both are granular, so you have to combine together. If you remember that case, we consider 200 only when if the base layer is different, say CTB. But here this is not CTB. This is not CTB. This is granular only. So we need to consider both together, and it will be 450. Now, tell me
Sir, 224.47.
24.47 MPa. What about this binder course? Binder means bituminous mix. Considering this, will be E1, mu1. E1 is 0.35 as given in RSA. What will be E1? Just here we have seen it's PG40 and modified bitumen. So 3000. Okay. 3000 MPa.
Sir, how did E1 come from?
E1, say this E1 is elastic modulus of the bituminous mix. So we need to find out which material you are using. Okay, so this materials we fixed, right? How did we fix the materials? Based on the traffic. Traffic is 84.9 MSA, right? So if it is 84.9 MSA, we need to go there. We need to go there. We need to go there and check if it is more than 50 MSA, what we can use. So we have used bituminous concrete with modified benders. Assuming, say we have used this for surface course. For binder course, what you are using? The dense bituminous with PG40 bitumen. It's a bituminous mix. In the upper layer, you have used modified bitumen. Here, you have used modified bitumen. And here, you have used PG40 bitumen. Okay. So now, the code also gives that if the bituminous layer is prepared with PG40 or modified bitumen, you can consider this E value as 3000 MPa. And presence is here 0.35. Understood?
Yes, sir.
Yes, sir.
Okay. So if the traffic is less, and suppose you are using PG30, then you could have taken 2000 MPa. In our case, traffic is high, that's why we are using modified and PG40 bitumen. You will use this. Okay. So this is what subgrade. This is here. U3. U3 is 35. This is your E2, basically E2. And this is mu2 is 0.35. And for binder iron surface, this is surface course with modified bitumen, BC with modified bitumen, DBM with PG40 bitumen. So in absence of test data, for both the bituminous mixes and questions. So this becomes your E1, this becomes your mu1. So this is the summary of trial 1. Trial 1 is like still we need to analyze, find out the strain. Okay, but can you draw this figure accurately, because we will be needing this while solving the numerator to like finding out the strain values tomorrow. Done?
Sir, please wait a minute. Done, sir.
Others, Vivas, Ankur.
So what? Yes, sir.
Done?
So done, sir.
Okay. So you'll use these values. Now, next is calculate the permissible strains at the critical locations. So here we have to find out the strains. So that cannot be. So this permissible strains can be found out using the formulas. This long formulas we have written. You remember? I think you must have written those formulas.
Yes, sir. NF.
So can you Ankur and Bivas, did you also write these formulas NF and NR?
Yes, sir.
Did you write?
Yes, sir.
Okay. So can you give me epsilon V? So this NF, NR, and design all are same. And design you already know 84.9. Or if you have the accurate value, you take the accurate value. What is the accurate? 84890. This is your N design as well as NR as well as NF. Static life, wetting life. All are same. Okay. So use this and find out what is epsilon V. You will tell me first. What is epsilon V? Means the maximum permissible vertical compressive strain at the top of the subgrid. Yes.
Sir, since we're taking MS, we have to multiply by 10 to the power 6.
No, I told you, no, you take the accurate one. Don't take like this. 8489 something you got, no? Take as it is, that one.
Okay.
What was the value? Was it 84?
Sir, 8489056
56?
8.64.
8.
8.64.
Okay, point you can ignore. So this is your NR. Now I really doubt whether you know how to use the calculator properly or not. Because it just takes 10 seconds. You put everything and you solve. Come on, how much?
So 3.3 into 10 to the power minus 4.
3.3.
Yes, sir. 3.307 into 10 to the power.
Yeah, you have to be a little bit accurate. Yeah? Because
3.33 into 10 to the power minus 4.
okay, I think you made some mistake here, maybe here. I don't know. Anyway, it is 3.3073 into 10 minus 4. So this strain doesn't have any unit, but we call it micro strain because 10 to the power minus 6 is micro, right? Okay, 330.73 micro strain, we can say. No, this is not its unit, just we are expressing, just to avoid this 10 to the power minus 6 strain. Okay, strain doesn't have any unit. So 330.73 micro strain. Everyone agrees? Proceed. You just want to execute.
Yes, sir.
Okay. Now for this fatigue of bituminous mix, this MRM you already know. This is basically E1 3000. Okay. C value of C, if you go back, go back. The value of C, okay. So actually for different traffic or in different catalogs, it's already given. Our catalog is A, okay, and traffic is like 84 MSA. So for 50, whatever is there, we will consider it. So for 50, you can say your VA is 3.5, VB is 11.5. So you can put those values here and you can calculate M. After calculating M, you can simply put the value of M here and you can get C. So C will come out as 2.35. It's already given in code. Okay, so C is your 2.35 that you will directly get from code. So C is 2.35. MR you already know 3000 because this is static, no? Static or bituminous mix. So you are calculating here. When you are calculating here, you need to consider MR of this bituminous mix. How flexible this is, like that. Okay. So are you getting this? If you don't get, then let me know. Sometimes I may be wrong. So
Understood, sir.
are you getting this value?
Yes, sir.
Viva Zonku, have you got 155.47 microsleep?
So calculator.
Yes.
So calculator.
Okay.
Yes, I got.
Others? Not getting? Simply you have to write as it is in your calculator. Then simply click shift this calci option, no? Solve. While solving, just give a nearby value, 0.0004 like that. It takes less iteration. You will get it anyway. Can I move to the next slide?
Yes, sir.
Okay.
Yes, sir. So good.
Okay. You just write down the value, you will get. So now we know that the permissible strain is this much, or this much of traffic, this much is permissible strain. So if the generated strain because of the load is more than these values, then that pavement will fail. If it is less, the pavement will survive this design life. So these values cannot be changed. It will only get changed if the design traffic, this m value is changed, right? So these values are fixed for a particular design life or R, everything by considering everything. This permissible values are calculated. Now, what is the generated strain? The generated strain is like we need to know how much load is coming, right? We need to know where to calculate, what are the points where it should be calculated, right? That we already know at this layer and at this layer. And at this layer also 2 points, like it can be here, it can be here, it can be here, it can be here. Sometimes it can be at the edge of the triangle also. It can be here, it can be here. There can be 6 points. 3 points for tensile strain, 3 points for particle strain. Where you need to analyze and find out what is the strain. Okay, so that we will find out tomorrow using software. So see, this is a software which I don't want to give like for free to all the students if they are not interested. So only Kaushik, Vivas and Ankur, I think you will be attending tomorrow's class as well. I will just assume. Will you?
Yes, sir.
Okay. So Vivas and Ankur, I think they will not.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. So I will give this software to you personally. So can you please send me a WhatsApp message here? Okay.
Okay, sir.
Okay. I will give you the link. You can download. It's a very like not a heavy software. Simply install. You will be able to install. After installing, you should get a screen like this. Like this. Can you take a screenshot? Done?
Yes, sir.
Done, sir.
So you should get a screen like this. So that means your software is installed. Okay. So I will give it to you. So before coming to tomorrow's class, please install that software and come. Okay. Thank you. Thank you for attending.
Thank you, sir.
Thank you, sir.
See you tomorrow at 6.
Okay, sir.
Okay, sir.
Okay, sir.
Bye.